Okay, so problem 3 is actually quite similar to problems 1 and 2, so I'm not going to spend nearly as much time on this problem as I did for the other ones. The main thing I want you to keep in mind is that in problems 1 and 2, you had no shear and no moment in A and B, between A and B. You only had shear and moment between B and C. In other words, you only had shear and moment where you had a load. In problem 3, that is no longer the case. You will have shear and moment in both the vertical section and the horizontal section. So I don't want to. I think that'll be good practice for you to go through that. But there was some questions on how to draw a diagram for elements like this where you have shear in both cases. I'm just going to draw you a diagram for like a hypothetical case. So this isn't really relating back to problem 3 at all. This is going more general. This is more like a video on how to draw diagrams, I guess. But if you have, for example, I don't know, let's say for some reason that you had a load that gives you a shear diagram. You had loads on the top and bottom members, and that gave you a shear diagram like say it was like this, and then we had something like this. I'm drawing my diagram. I'm drawing all my forces directly onto my diagram. And let's say, for example, that I had some. This doesn't really make sense for a shear diagram, actually, but the point I'm just trying to show is that you can draw both your vertical and your horizontal forces on the same diagram. So this was my diagram originally. I drew in my forces on top of my diagram. So this was my positive axis for this vertical member. This was my positive axis for my horizontal member. If I wanted to, then if I wanted to shade this in, for example, I would say something like, I would shade them in. I would use hashes that were going in opposite directions. So for this top member, I would put my hashes in going this way. For the bottom member, I would put my hashes in going this way. And that's how it would distinguish visually between the two overlapping areas. If I'm working with a frame that is on all sides, so let's say that this was my frame, then I would do the same thing. Now let's pretend that I'm drawing I have my diagrams going this way. They're all pointed outwards. This is for shear again, and then I would have my values something like, I don't know, let's say that was my shear diagram or something. I would again draw my shear, my hashes going, for example, this way, and my hashes going this way. So you can see, like, I can tell I have some overlap here, but I can still read my graphs because I have the hashes going in different directions. And other than that, that's mainly it. The only thing I wanted to say for number 3 was that make sure you keep in mind you should get moments in both arms. Because you're getting moments in both arms, both of these are going to deflect. So in problem 1 and 2, you only had deflection between B and C. B rotated, but you had 0, it didn't bend or anything. The only bending you had was in BC. Now you're going to have bending in both arms. Other than that, if you have any questions on this, let us know.